Hello student, today we are going to perform the experiment, the name to study the induced EMF as a function of velocity of a magnet. Before finding the readings, we have set up the connections. For setting the connections, understanding this diagram. In this diagram, firstly, the one end of the coil connected with the resistance and second end of the coil connecting with the diode and next end of the coil connecting with the capacitor and the voltmeter. Now again capacitor and voltmeter connected to the galvanometer and last galvanometer connected with the second end of the coil. Now look at these apparatus. Here we have connect the one end of the resistance with the next end of the coil and second end of the resistance connect with the negative end of the diode and positive end of the diode connected with the capacitor. Okay, now in the capacitor again we have connect the capacitor with the voltmeter and second end of the capacitor connect with the common of the voltmeter. Now again we connect the galvanometer to the voltmeter and last we have connect galvanometer to the second end of the coil. Now let's start taking the reading. Now resistance, which resistance we connected? Here we have a four type of resistance: 100 ohm, 1 k ohm, 5 k ohm and the 10 k ohm. I have connect the 100 k ohm. Next capacitor. So here two types of capacitor, 1000 microfarad and 470 microfarad, and I have connected the 1000 microfarad. Again the time period of apparatus. For finding the time period of apparatus, firstly we have taken 10 oscillation and with the help of stopwatch we have calculated the time of the 10 oscillations. Now start. 1 2 3 4 5 6 7 8 9 10. Now stop this stopwatch and note the time period. So we have get the time 17.63 and now we have take 10 oscillations, we have divided the 10. We have get the value 1.763 second. Okay. Again we have calculated the radius. For measuring the value of the radius, we have take a scale and measure from the center of the coil. Take it the value, it is approximately 27, and from the end of the coil, we have take again some values from this end and also from this end. And after getting the values, we have find out the mean, and we get the mean of this value 27 centimeter. Now look at it, the table. In the table we have firstly find the value of theta naught in the degree and in radian. After that the value of the volt in from with the help. So firstly we have taken angle theta. For taking angle theta, I have taken needle at 30-degree angle. So start oscillate, and after oscillate you have seen that there is a deflection in the galvanometer. After stopping this, so when the needle is stopped at the 0, I have recently pressed the voltmeter and you have seen there is some value of the voltmeter. Now I have connected 3 volt. Okay, we have connected 3 volt and there is 2 volt values, 1.5 volt and 3 volt. So I have taken the 3 volt, so I am taking the readings of the 3 scale. Okay, if we have take the 1.5 volt, then we have take the value of the scale 1.5. So firstly we find the least count of the scale 3. For finding the least count, we have count the lines. We have approximately 10 lines, so 10 deviation is equal to 5. So for finding the one deviation value, one deviation is equal to, so we have a 0.5 and one deviation is equal to 0.5 divided by 10, 0.05. Now the value of voltmeter, let us suppose we have a value 6. So we have taken a 30 degree, and for finding in the radian we multiply 30 degree into pi by 180 degree, and we get the voltmeter value 6 into multiply with least count 0.05. Now again at the same angle we again find out the reading for this and find the mean. Again we put the value like theta naught in the radian, we have put the value of theta naught, and r naught that we have a radius, and time period that we have a find out already 0.6 second. And after this calculation we also, after 30 degree again we take the 40 degree angle, 50 degree and so on. And at last, after taking a reading, we have plot a graph between the induced EMF in volts and the maximum velocity. After getting a straight line graph, your reading will be correct.